But if the open-ended would be that point problem. Remember that? Like graph the coordinate point and find the 6 things, right? This is what the multiple choice from this section will be. So like I've been doing that every day. So all of the things that you've seen so far is what it looks like. All right? So for this first one, go ahead. Yeah, we'll go in all kinds of orders, but yes. So what is 210 degrees in radians? Well, 210 is somewhere in quadrant 3, right? Between 180 and 270. So just kind of logically speaking here, it's going to be somewhere between 1 and 1.5 pi. So I can look at these fractions and figure out what definitely can't work. Like this is less than 1, 7/12, right? So it definitely can't be that. And 6/7 is less than 1 as well, so it can't be that. And 210 pi just seems illogical, right? It just adding a pi back. Look, I got C and I didn't even do any work at all, right? So that's one way to do it. Think about like where it should fall and what you know about it. The way to actually do it though is to use the conversion ratio. So 210 degrees times, and then we'll put the 180 degrees on the bottom and the pi on the top. So when we multiply straight across, it's 210 pi over 180. And then if I put this part into the calculator and simplify it, I'm assuming that's 7/6. Right, so that's where the 7/6 pi is coming from. But I got that answer, I got C without actually doing any work at all, if you understand the corners of the unit circle, right? So first one is C, 7 pi over 6. Determine the quadrant for 5 pi over 3 and find its reference angle. Okay, well, 5 pi over 3 is like 1 and 2/3. Right, because 3 over 3 is 1, and then I've got 2 left over. So that's like 1.67 pi. So that looks like that's going to fall somewhere between 1.5 pi and 2 pi. Which means it's going to be somewhere in quadrant 4. Now, if that doesn't make sense to you, you could do a conversion. You could change 5 pi over 3 to degrees. And degrees might be easier for you to graph. So if you're having a hard time graphing in radians, change it to degrees, all right? So this is somewhere in quadrant 4. So I know the answer is not A or B, because those are quadrant 3 answers. And then it says find the reference angle. So I need to draw a reference triangle. And I need this. All right, so this is 5 pi over 3. I need to go a little bit more to get to 2 pi, right? The full rotation. So I'm doing 2 pi minus 5 pi over 3. When you are adding and subtracting fractions, you need a common denominator. So I need to give this a 3 and this a 3, which ultimately makes that a 6 minus 5, or a pi over 3. So the answer to this one is C. Everybody okay with that? All right. Question 3 says, given the information, find the quadrant. So remember, we know that all students take Calc. So this first piece of information is that cosine theta is negative 3/4. So I have to think about where cosine can be negative. So it's positive in 1 and 4. So my answer is either 2 or 3. So it's not B, it's not A. Right? And then I'm thinking about sine of theta is greater than 0. So sine of theta is positive. Well, sine is positive in 1, 2. So it's not 3. What they have in common is quadrant 2. So the answer is B there. I'm doing all students take Calc and seeing what they have in common. Cosine is negative in quadrant 2 and sine is positive in quadrant 2. Last one says solve the equation from 0 to 2 pi. Well, it's cosecant, so I'm going to have to change it to sine. And to do that, I'm going to have to flip that fraction. So it becomes a negative 1/5. And then I'm going to find the reference angle. And I'm going to find the reference angle by doing the sine inverse of 1/5. I'm not going to include the negative. But because of this direction here, when I do that, I'm going to make sure that I am in radian mode in the calculator. So I'm going to switch my mode to radian. If it's not there, it is. And I'm doing the sine inverse of 1/5. I'm not including the negative. 0.2 is my reference angle. I need to apply that 0.2 to two places. Sine theta is negative 1/5. So I have to think about where sine is negative. Sine is positive in 1 and 2. So it's negative in 3 and 4. So I need to use my quadrant 3 and 4 rules here. You can draw a picture if you need to, okay? Quadrant 3 is pi plus the reference, and quadrant 4 is 2 pi minus the reference. If a picture helps you draw the picture, draw the triangle in. You have the small angle. You're looking for the big one. So pi plus 0.2 and 2 pi minus 0.2. So 3.34 and 6.08. Test taking strategy. You don't have to do any of that if you know how to use your calculator. I want sine to be negative 1/5. I want sine to be negative 1/5. I want sine to be negative 0.2. So what I could do alternatively here is, if I forget what I'm doing, I could type sine of 191.54 into my calculator and see if I get negative 0.2. So not negative 0.2. So A is not the answer. So then I say, okay, well, let me try B. Sine of 0.2. That's positive 0.2, but I need negative 0.2, so that's not the answer. So then I go to the next one. Sine of 1.2 pi. That's not the answer, so then maybe it must be the next one. Let me do 3.34. That's negative 0.2. Right, so you can just plug it into the equation. That's what it's there for with multiple choice. If you know how to use your calculator, the thing is, if you don't have your calculator in radian mode, none of that's going to work. So you have to understand the question at least a little bit to get there. But the answer for this one's C. All right, so you're going to see all of those types of questions on your final exam. Those are from the calculator section. Today we're going to work on the unit circle. So being able to fill in the unit circle and then being able to evaluate the unit circle. All right, so in your packet, this is on page 12. In your final review TAN packet, this is on page 12. You should see a blank unit circle on page 12. All right, you are going to have to be able to fill it out. Now, not in its entirety, right? So, like, you only need to be able to fill it out for the questions you're on. Part of your test is not filling this out, but you're not also going to have one. So the questions that you need to use it, there's going to be one that's blank for you there, and you can or cannot fill it out. It's totally up to you. Okay, but you'll have the option to fill it out. So when we did the unit circle, our strategy was, let's go through from the inside up. 3, 2, 1, and then the outside is 1, 2, 3. Right, for our coordinate points. It's 3, 2, 1, 1, 2, 3. Everything gets a denominator of 2. And all of the numerators get square roots except the 1's, because the square root of 1 is just 1. Right, so I'm going to have square root of 3, square root of 2. I'm not going to put square root of 1 though, because the square root of 1 is just 1. All right, In those places, the angles that we memorized were 30, then 45, and then 60. Anybody remember the radians for those? Yeah. Good. Good. All right, so we got to know those. And then to get the tangents, we do y divided by x, or maybe you memorized it, okay? So to get the tangent of these places, you're doing the y value divided by the x value. This one ends up being root 3 over 3, 1, and root 3. So that's everything you need to know about your quadrant in one parts. And then there's also corner parts, and those you already know. We've been kind of working with them all along. So this is 0 degrees and 360 degrees, which is 0 and 2 pi. To get to this point here, you're going over 1, but not up anything. So that point is 1, 0. And y divided by x is 0 there, so the tangent is 0. This point is 90 degrees, or 0.5 pi, or pi over 2. You're going to get to this point, you're going left and right 0, but you're going up 1. And when I do y divided by x, I get an error. We call that undefined, or error, or does not exist. The tangent doesn't exist at that place. Alright? And then over here is negative 1, 0, because you're going to the left. 0 divided by negative 1 is 0. This is 0 degrees and 180 degrees. Or sorry, 180 degrees and pi. And then finally, this is 0, negative 1. That's 270, 3 pi over 2. Tangent is undefined there. You do not need to know every little aspect of this circle. Like if you forget a part, you're still probably going to be fine, okay? There's just a few questions where you need to refer to it. So the basics is important. But this, I just wanted to refresh your memory because it's been like 2 weeks since you've seen one completed, right? So once we have one completed, there's going to be 2 different things we're going to do. The first thing is I'm going to give you the angle, and you're going to give me the coordinate point. The second thing is I'm going to give you the coordinate point, you're going to give me the angle. A lot of you on the quiz confused that, right? I think you're always picturing solving the equation and giving me the angle, and you forgot about the part where I give you the angle, you give me the coordinate point. So if I give you the angle, your answer is either 1/2, because that's a coordinate point on the unit circle, root 3 over 2, root 2 over 2. And there's a lot of 1s and 0s on the unit circle. So your answer, if I give you the angle, needs to be one of those 5 things. Root 2 over 2, root 3 over 2, 1/2, 1, or 0. And they might have negatives with them, right? But like the numbers have to be a coordinate point. So I give you the angle, you give me the coordinate. Here's how I do it. Sine of 90 degrees. I look at your unit circle and go to 90 degrees. Go to the angle at 90 degrees. You're looking at the coordinate point. I give you the angle, you give me the coordinate. In terms of sine, sine is the y value at 90 degrees. So look at the coordinate at 90 degrees. What's the y value? 1. So the answer to this question is just 1. I give you the angle, you give me the coordinate.
How do you know sine is the y value?
Sine is always y because in terms of like a triangle, sine's going to give you the vertical part, which is the y. And then cosine will always be x. Tangent doesn't have one, that's why we do y divided by x. Alright, so cosine is x. So really what I'm looking for is the x value at 150 degrees. The problem with this one is it's not a quick one because there's no 150 degrees on my unit circle, right? So let's think about 150 degrees. What quadrant's it in? 2. Okay, so I can then take that and I can draw this reference triangle. This is 150. So what's the green angle? 30. So to answer this question, I am going to have to refer to 30 degrees. I don't have a 150, but I do have a 30. So what's the x value at 30 degrees? So root 3 over 2. All right, so root 3 over 2 is going to be my answer. However, I have to think about, now I'm in quadrant 2. What do I know about cosine in quadrant 2? All students take Calc. It's got to be negative, right? The x value is negative as we go to the left. So I have to add a negative to this. Cosine of 150 is negative root 3 over 2. You have your calculators. Unfortunately, they're not going to do a lot for you for these problems. You could have got this answer in your calculator. But if you type this into your calculator, you are going to get an irrational decimal because root 3 over 2 is irrational. So you're going to get a decimal. It's not going to give you the exact form of the answer. So even though you have your calculator, which might help you check your answer, it's not going to give you the answer. So if you're really struggling with understanding that that's a negative, you could use your calculator to help you with that part. You just got to make sure you're in degree mode because 150 is degrees. So cosine of 150 is a negative number. I just don't know what negative 0.86666 is. So then if you have really good math sense, you can be like, all right, well, it's got to be root 3 over 2 or root 2 over 2, right? Because 1/2 would have come up nicely. And you could just check them both. So you could work backwards with the calculator, but kind of helps to have the starting point of the unit circle. 4 pi over 3 is an angle. It is not a coordinate point. Coordinate points, 1/2, root 3 over 2, root 2 over 2, right? If I give you the angle, you're giving me the coordinate point. So I have to think about 4 pi over 3. It is not an angle on the unit circle. We have pi over 3, we have pi over 6, we have pi over 4. We don't have 4 pi over 3. What do you think the reference angle is? Pi over 3, pi over 6, or pi over 4? It's got to be pi over 3. I don't even need to do the work, right? It's got to have the same denominator in order to be the reference angle. Now, if that doesn't make sense, you can draw it out. 4 pi over 3 is 1 1/3. So it's bigger than 1, but it's less than 1/2. So it's somewhere here in quadrant 4. And if I draw a triangle for that, this is 4 pi over 3. So this is pi plus a little bit more to get to 4 pi over 3. 1 plus 1/3 is 4 thirds. So that's pi over 3, that orange. So my reference angle is pi over 3. So I can't tell you what 4 pi over 3 is, but I can go to pi over 3 on the unit circle. But it's secant, and my unit circle gives me cosine and sine. So I have to think, okay, well, secant goes with what? Cosine. So the cosine at pi over 3, the x value at pi over 3 is 1/2. Yes? Yeah. Right? The x value at pi over 3 is 1/2. So what's the secant there? What do we do to get secant? We flip it, right? So it's 2. So the secant of pi over 3 is 2, but remember, we're in quadrant 3 now. So should it be positive or negative? All students take. Tangent would be positive, but everything else is negative. This is negative. When they work up nicely like this, the calculator actually does work. Okay, you just can't use, there's no secant button, but you could do the cosine of 4 pi over 3 and then flip it. It's not one of those weird decimals. I give you the angle, you give me the coordinate point, right? So 7 pi over 4 is not an angle on the unit circle. The unit circle is pi over 3, pi over 4, pi over 6. What do you think the reference angle is? It's pi over 4, right? It's got to be the over 4 one. So I'm not even going to draw the picture. I'm just going to refer to pi over 4. The tangent, because cotangent goes with tangent. The tangent at pi over 4 is 1. Right, if you look at what we filled out for tangent. So the cotangent at pi over 4 would be to flip 1 over 1. What do you get when you flip 1 over 1? Still 1. So the cotangent at pi over 4 is still 1. What quadrant is 7 pi over 4 in? 7 pi over 4 is like 1 3/4. 1.75. 4. Because 1.5 is that cutoff. We're at 1.75. So we're in quadrant 4. What do I know about tangent in quadrant 4? So my answer is not just 1, it's negative 1. Look, if I go to my calculator and I switch my mode to radian, I can do the tangent of 7 pi over 4. I just can't do cotangent. There's no button on the calculator, so you could try it in your calculator and then just flip that. I'm getting negative 1 still. You can use your calculator for a lot of these now that you have it. It's just if you get a weird decimal, 0.86666, 0.57 something, just know that that's either got to be a root 2 over 2 or a root 3 over 2. It's got to be one or the other. So all of these are, I give you the angle, you give me the coordinate. There is another one. The next examples are, I'm giving you the coordinate, now you need to give me the angle. See how there's a theta in there? Theta is the Greek symbol for angle. Okay, so I'm saying, I don't know what the angle is. You tell me. I'm going to tell you what the coordinate is. So when we go through and work this out, we're going to either get a 1/2, a root 3 over 2, like our actual math is going to give us a coordinate point. And then we'll find it on the circle. So the first thing you do, we did these yesterday, the first thing you do is you get rid of, so negative 4/8 is the same thing as negative 1/2. There is no negative 1/2 on the unit circle, right? So I need a reference angle for this. I need something to refer to. Cosine is x, right? So what I'm looking for on my unit circle is, where is x 1/2? 60 degrees. And the question does say 5 and 6 we're going to do from 0 to 360. So we're going to use the degrees. So I am going to refer to 60 degrees when I answer this problem. I don't know where cosine's negative 1/2, but I know that it's 1/2 at 60 degrees. Everybody okay with that part? So where is it negative 1/2? Well, what quadrants can cosine be negative in? 2 and 3. So what I need to do is I need to apply 60 degrees to quadrants 2 and 3. So it's, some of you end up drawing a picture here and some of you don't. I don't care how you do it. Use the rules, draw the picture. I'm drawing something in quadrant 2. And I know that this is 60. I want this. That's my answer. So what's that number? 120. 180 minus 60. So my first answer is 120. I gave you the coordinate point. You're giving me the angle. Okay, the second one would be something in quadrant 3. So this is 60. I want that. I want 180 and then plus 60. So that's 240. Just remember, you have a calculator right now. So now that on your final, you do have a calculator, you could always check these. Cosine of 120 and cosine of 240. Just make sure you're comfortable switching your modes in your calculator, because that's degree. Cos of 120, cos of 240. Both are negative 1/2. That's what I want. Alright, so those are your answers. Alright, let's look at the next one. If I subtract 5 and then divide by negative 3. Sine of theta equals 0. Now, there's nothing to refer to here. because reference angles are angles between 0 and 90. So those are the coordinates in quadrant 1, your 1/2, your root 3 over 2, and your root 2 over 2. That's not any of those. So there's no reference. Because y is never 0 inside of quadrant 1. So instead, all I'm going to do is find where y equals 0. Look on the edges. Coordinate points work, or corner points work differently. Edge points work differently. So I just look on the edges and see where y is 0. And in degrees, that's 0, which is the same thing as 360, and 180. Those are the two places that the y value is 0. Those are those are coordinate points. Answers are angles. All right, now 7 and 8, we're shifting gears. We're gonna, instead of working with the degrees, we're gonna work with the radians. The questions say from 0 to 2 pi. So I don't have to do any solving here. What I have to do is switching, because secant's the same as cosine. And if I'm flipping that, it's 1 over root 2. But if I rationalize that, that's root 2 over root 2. So my reference angle, the angle I'm going to refer to, is where cosine, which is x, is root 2 over 2. What angle is that? 45 degrees, which is in what in radians? Pi over 4, because we're doing this one from 0 to 2 pi. So my reference angle is 45 degrees, but in radians, that's pi over 4. Now what I need to do is figure out where this is possible. All students take calc. All of these have 2 answers except maybe your corner ones. All right, so this is cosine and it's positive. So I have a quadrant 1 and a quadrant 4 answer. Quadrant 1 answers are nice. What do we do with quadrant 1 answers? It's just the same. So my first answer is pi over 4. And I could check that. Just know that I'm in radian mode now, so I'd switch back. And I would make sure that cosine of pi over 4 is the same thing as root 2 over 2. So that one works out. But there's one more, and it's in quadrant 4. That's right. How'd you do it? You can totally do it that way. Change it to degrees and work your way back to radians perfectly fine, because you have your calculator now.
You put 2 pi over 1 minus 8, and then make that 8 pi over 4.
Yes.
So they make the same
So
denominator.
so the key here is I'm doing 2 pi minus, right? Quadrant 4 is 2 pi minus. You need a common denominator if you're doing this by hand. So you got to give this a 4, which gives this a 4, which makes that actually 8 minus 1. So that's why she's getting 7 pi over 4 here for the second one. 8 minus 1 is 7 pi over 4. And you can check that too. Cosine of 7 pi over 4 should be the same thing as root 2 over 2. So you can check your work now that you have your calculator back. What I don't want you to give me is something like 0.707. Don't make pi over 4 a decimal, okay? These are going to say in exact radical form, so you need to have the roots perfect. You need to use the unit circle. All right, last one. I've got a cotangent. So I'm going to divide this out, but I need to change it to tangent. So I'm going to flip that. Nowhere on my unit circle do I have a negative root 3 over 3. So that's why I have to use a reference angle. What angle has a tangent of root 3 over 3? 30 degrees, which is pi over 6, if we're answering this in radians. And then I need to, because pi over 6 is in quadrant 1, it's not on an edge, then there should be 2 answers. So I need to figure out my 2 quadrants. Tangent is negative root 3 over 3. So where's tangent negative? Where can tangent be negative? What 2 quadrants? 2 and 4. So my answer is going to be in 2 and 4. So I'm going to apply this to quadrant 2 and 4. You can draw a picture like Mahari did. She switched it to degrees, figured it all out in degrees, because sometimes that's just easier to see, and then to change it back to radians. That's totally fine too. In quadrant 2, the rule is pi minus, and in quadrant 4, it's 2 pi minus. For both of these, you need to make common denominators. So I'm going to give the tops and bottoms 6s. So that's going to make a 6 pi minus 1 pi. So 5 pi over 6. And that's going to make a 12 pi minus 1 pi, or 11 pi over 6. What do we think? If I give you the angle, you give me a coordinate point. 1/2. Root 3 over 2. 1, 0. Those are your answers. If I give you something like this, which is coordinate points, you give me angles. Usually the angle ones have 2 answers. So I have your practice today being in multiple choice format. So if you go to page 13, you'll see similar questions to the multiple choice from this section. There is one open-ended from this section. So yesterday's was, here's the coordinate point, give me the 6 trig values. Today, it'll be like that last problem we did, or one of the last problems we did. It's not necessarily tangent, right? But it's the solve for the multiple angles. And then your third open-ended is a sine and cosine curve table, like the unit we just finished. So I'm going to go over the answers in 8 minutes, so that way we go over them before you leave today. All right, guys, just in case you looked at this, 120 is something in quadrant 2. And I know that that's 120. So that must mean that my reference angle is 60. So I'm referring to 60 degrees when I do this. And the 60-degree quadrant, or coordinate point, is 1/2 comma root 3 over 2. And secant goes with cosine, and cosine goes with x. So I want to focus in on the x value of this, which is 1/2. But secant is the flip of that. So I'm going to have to take that 1/2 and flip it, which is going to give me a 2. Everybody okay so far? All right, so I'm referring to 60. Cosine of 60 is 1/2. So secant of 60 is 2. Now I just need to take into account that I am somewhere in quadrant 2. All students, sine is positive, but I'm working with a cosine function. So I also need to put a negative here. The answer is 2. While you can't use your calculator to do the entire thing, you can use your calculator to do this. Okay, if I know that secant goes with cosine, then I could do, let me just make sure I'm in degree mode. I can do the cosine of 120, and then just flip it. Right, the cosine of 120 is negative 1/2. So the secant of 120 is negative 2 over 1. So you can use your calculator. It does work. All right, the answer to that one is D. What is the tangent of pi over 6? So this one is in quadrant 1, so you just literally have to look at the unit circle if it's completed right. So the tangent at pi over 6 is root 3 over 3, right? Or go to pi over 3, look at the coordinate point. Root 3 over 2, comma 1/2. Tangent is y divided by x, but I'm going to keep change flip. So So I end up with 2 over 2 root 3. Or 1 over root 3. And when you rationalize that, that's where the root 3 over 3 is coming from. A lot of you just memorized the tangent though. You didn't actually do the math. That's where it's coming from. Or type it into your calculator. Just make sure you were in the right mode. This is radian. So go to radian. Type tangent of pi over 6. There it is in decimal form. And then check each A, B, C, D decimal. And see which decimal matches. Root 3 over 2, or root 3 over 3 is the decimal that matches that one. That's how you could pick A. Just another way you can do it. All right, and then the last one, I'm solving for this equation. So I'm dividing by 2. So I have cosine theta equals negative root 2 over 2. Well, even just from looking at this, I know that the answer can't be this because there's only one answer. I also know that my answers have to be cosine's negative, right? So it's got to be something in quadrant 2 and 3. Well, that is in quadrant 1, so it's not that one. All right? So it looks like the difference is 7 pi over 4 and 5 pi over 4. Well, 5 pi over 4 is 1 1/4, and 7 pi over 4 is 1 3/4. Which one of those two things is in quadrant 3? 1 3/4 is in quadrant 4 because it's bigger than 1.5, right? So I know that the answer is this, and I didn't do any work. Okay, you can do work though. Find the reference angle. The reference angle is pi over 4. Apply that to quadrant 2. Pi minus pi over 4. Give it 4s. That's 3 pi over 4. That takes care of the first angle. In quadrant 4, 2 pi minus pi over 4. Give it 4s. Oh, it's not quadrant 4, it's quadrant 3. Ignore me. In quadrant 3, it's pi plus my reference angle. Give it 4s. 4 plus 1 is 5 pi over 4. Or type each one in your calculator one by one and see which one works for both. Alright? So just an idea of what you're going to see from this section in terms of multiple choice. I also wanted to go over strategies with you on how to approach that, especially because I'm not going to see this in you again, right? So you take the final with me on Friday. So if you want to do extra review in your own time, there's the white packet. That's your final review guide. You guys know what I'm talking about? Looks like this. This is all like just independent practice. So you can work on this. What you're missing, seniors. Tomorrow we're going to review graphing, which a lot of you did with me on the junior prom day. Right? Remember, like domain, range, vertical asymptotes, all that. That's what we're going to review tomorrow with the juniors. And then the next day we're going to review simplifying rational expressions, which was our first unit. There's only one question on your final, that's that. So you're really not missing that review day. It would be the graphing, which I did do with a lot of you on that junior prom day. But if you also miss the junior prom day, then you're missing a big day of review. So you might want to watch the video or do some practicing. Oh, really? Oh, great. Oh, great. Look at, never mind. Ignore me. Then you're not missing anything on Thursday. Thursday, you're going to miss one problem. It's the first question on the test. If you get one problem wrong, you're going to be fine. All right, then I totally misjudged that. And seniors, some of you are going to sit through the same lesson twice because we did this already. You were here twice. I remember you were here, Sean. I forget what other.
Do we do extra time for